In this video, we are going to the second portion of AQA A Level Physics with the paper code over there. That is 7408. Paper 1 over there I was solving. First 5 questions are done in the previous video. The link is given in the description for the start of this paper over there from question number 1 to question number 5. Today we will have to go with the question number 6 over there. If you have not subscribed my channel, kindly subscribe my channel and so that you can find the latest paper solutions which will be uploaded by AQA website over there, and you will find the exact solutions with the complete detailed concepts over there. Let's move towards the question number 6 there. All right. Question number 6 states that the circuit in the figure 5 is used as a part of a temperature sensor. Okay. The battery of EMF 6.5 volt with internal resistance, negligible internal resistance. It means there is no resistance right now. Now he is saying that the initial temperature of the thermistor, this is the thermistor which is shown over there, is initial temperature is 22 degrees centigrade. At this temperature, the resistance of the thermistor is 350, means 22 degrees centigrade. Resistance is 350 ohm over there. And the circuit in the current is 12 milliampere. So the current is coming from positive terminal of the battery to negative terminal of the battery. That is being taken as 12 milliampere over there. Okay, let's go to the question now. Here he is saying calculate the resistance of variable resistor over there. If we say the resistance to be taken, then I will say here that when 350 ampere, if I take the resistance in total for the main resistor 6.5 volt and 350 is being taken over there, then the resistance total will be calculated with the help of the formula. The resistance of the variable resistor, I will subtract it from the thermistor resistor later on, but R is equal to V over I. So V is being taken as 6.5 volt. 6.5 volt divided by current is given 12 milliampere, 10 raised to power minus 3 there. Then if I go for this one to calculate over there, then it will be 6.5 divided by 12 multiplied 10 raised to power minus 3 over there. Then it will give me this. It will be giving us 541.66. 541.66. So it is R total of the whole circuit, which I am saying here having the value 541, 542 I am taking. 542 ohm. This is the total resistance of the whole circuit. And if I subtract or minus the thermistor resistance of 350 over there, I will get the resistance of variable resistor, which was the second component in my main circuit over there. If I can show you here, this is the thermistor and this is the variable resistor over there. So just subtract the 542 with 542 minus 350. What you will get over there? 542 minus 350. 50 will give you this, will give you 191, which I can say 191.77. It means 191.77, which I can take here 192 ohm as the resistance of the resistor over there, which was the fixed resistor. After that, he is saying that the resistance R naught, which is original for the thermistor at temperature, we can say 0 Kelvin or like that, which he has given for us, is given by R naught e power B with 1 over theta minus 1 over theta 0. R0 is the thermistor, is the R naught is the resistance of at the initial temperature of theta degree centigrade in Kelvin, theta original in Kelvin, and B is a constant. The temperature of the thermistor is increased up to 318 Kelvin. All right, the variable resistor is adjusted so that the circuit current is again 12 milliampere. The potential difference across the thermometer is 3.2 volt. Determine the value of B over there. All right, for this one, I will say I will have to calculate the resistance, and on the basis of this, I will have to go for current over there, which I will say for this, first I will have to go for a proper unit also for the B over there. All right, let's go for its calculation. Then I will say uh, the formula which he has given me, that is R naught, R is equal to R naught e power B with 1 over theta minus 1 over theta naught over there is being taken in the form of, and this whole is in the exponential over there. Then I will say that for going the total resistance over there, which we have calculated over there, now I will have to go for the current when the voltage is now 3.2 volt. Then if I go for resistance, VR is equal to V over I, then V is 3.2 and 12 milliampere means 0.012. And to get my resistance for this one, that is that will be the resistance R, okay, depending upon the start of the thermistor over there. Let's go with it. The fraction introduced 3.2 divided by 0.012 is equal to, this is equal to 266.6. So I can say 266.7. So R is equal to 266.7 ohm is the resistance which is being taken with the help of 3.2 and 12 milliampere over there. Okay, so I will go for now the data which is given to me for the calculation of this one. Then I will say the given data is R naught original was 350 ohm. After that, the resistance of theta change in temperature, theta for temperature originally was 20 22 degrees centigrade. Yeah, 22 degrees centigrade. Then I will take my temperature as 22 plus 273, because we know temperature should be taken in Kelvin. So 3 plus 2 is 5, 9, 295 Kelvin is the temperature over there. And after that, theta, which is being obtained up to the simple value for the increment over there, which he has said over there, 318 Kelvin is given. That is increased over there, 318 Kelvin. And the resistance, which I will have to take as R over there, is being given by the value 266.7 ohm as the resistance over there. All right, just substitute all of these values into the given formula over there. How we will go for it, I will say R is equal to 266.7 is equal to 350 e power B. I want to calculate 1 over theta is 318 minus 1 over theta naught is 295 over there. If I want to arrange all of this, then I will say before going to anywhere, this 350 should be divided over there. 266.7 divided by 350 is equal to e power B into 1 over 318 minus 1 over 295. So when we should go for this, we can simply get it's 1 over 13 and minus 1 over 259. Okay, for this one I say 1 divided by 3118 minus 1 upon 295. 1 upon 295 is equal to this, which I take in decimal form, uh, 0.000245. Then I will say it is E power B into minus 0.000. After that, what was it? 245. 0.00245 over there. So it is the exponential form. And if I take 266.7 divided by 350, 266 divided by 350, it is equal to this. It is equal to 0.76. 0.76. And if I apply a logarithm on both sides, 0.76 will equal to ln E. I have applied here, and this whole is coming in the start over there. Ln E is 1, and whole coming in the start. And in the next step, I can write it B into 0.000245, and ln E is 1. No need to write over there. Just divided ln 0.75. ln 0.7576, sorry, it is 0.76. So I can say from here that B can be taken as take the natural logarithm over there. We can easily get that the natural logarithm from the B. Then I can say B is equal to ln 0.76 divided by 0.123245. And if we get for the solution over there, okay, ln 0.76 bracket close divided by 0.123245 equals to minus 1120. So minus 1120 minus 11 to 0. And if we say the value which we have taken above, this minus sign will be ignored by taking the natural logarithm on both sides, because in the start where when you were taking here the negative over there, this negative is coming also with it. This negative is coming also with it. With it, after the logarithm, you are getting minus, which will be cancelled out. So B is 1120, and the unit of B is taken in Kelvin. It must be the exponent of dimensionless. So it will be taken in Kelvin over there. Okay, B is the Kelvin K, and the most must take to exponent dimensionless over there. Okay, let's move to the next part over there, question number 6. Okay, B, what I said, the B value is 1120. 1120, and unit is Kelvin over there. All right. Explain why the current in the thermistor needs to be controlled. Explain why the current in the thermistor needs to be controlled. I'm just explaining in my keywords over there. Okay. As a large current would cause heating of the thermistor due to its power dissipation, and we can say P is equal to I square R. If we say that if a large current will be there, then the power will be larger due to heating effect over there. And the self-heating would change the temperature of the thermistor itself, and this would make the resistance measurement inaccurate for sensing the external environment temperature over there. Remember that I am explaining again for you. A large current would cause heating of the thermistor due to its power dissipation in the form of I square R over there. And this self-heating would change the temperature of the thermistor itself. And this would make the resistance measurement inaccurate for sensing the external environmental temperature over there. So the current in the thermistor must be controlled over there. Okay, let's move to the next part here. He is saying, explain how ammeters and voltmeters can be used in the circuit to demonstrate the conservation of charge and conservation of energy. Refer to the point X, Y, and Z in your figure over there. X, Y, and Z. Okay. For X, Y, and Z over there, if I refer over here and I want to calculate the voltage and current, I will simply say here that the conservation of charge will be controlled and ammeter will be placed at point X over there. I am introducing here an ammeter in series over there, and it will show the same reading as ammeter placed at point Z over there. And because the current in the series does not change, it remains constant over there. And demonstrating that the current rate of flow of charge is constant around the series circuit over there. If I introduce the ammeter over there also. And on the other end, when I will go for conservation of energy by using the voltage remains constant by using the voltmeter over there, voltmeter is placed at point X and Y over there, like in the form of parallel, for showing the voltmeter in parallel to be connected between X and Y over there. And on the other end, if you are using that X and Y, the battery will read the EMF, total energy per unit charge applied, and voltmeter placed across Y and Z over there will also read the will read Z. The thermistor over there will be taken. Thermistor and the reading over there will be used. And then I will say voltmeter placed across the Y and Z. Then the across the another N component that should show the sum of potential differences of both Vxy and Vyz will be having the sum equal to EMF of the battery, because internal resistance is negligible. So no voltage drop across the internal resistance will be taken into account. So demonstrating the energy supplied equals to the energy transferred to the circuit over there can be taken into account. This was your simple explanation that how you can place ammeter and voltmeter for showing the conservation of charge and conservation of energy. Conservation of charge by placing the ammeter, that current entering the resistors entering is equal to current leaving, and conservation of energy will be taken as voltage drop across XY plus voltage drop across YZ over there will equal to EMF over there. So this is the way how I will say that the charge will be conserved and energy will be conserved for this section over there. In an experiment is done to investigate um, stationary waves on a string. Okay, this is a waves related topic over there. A string of length 1.05 meter is attached between the clamp stand and a vibration generator. A stationary wave is formed. Okay, this, and there is a string between them of 1.05 meter length over there. Stationary wave is formed on the string when the vibration generator frequency is 625 hertz. Figure 6 shows of the variation of displacement with the distance from one end of the string at time t is equal to 0. At this time, all the points of the strings have the maximum displacement. S is 1 point on the string. Okay, S is this point which he has shown on the graph over there. Amplitude is taken like 7 approximately. Okay, and time period is being taken as 7 is 7 meter, and here it is also showing the 7 millimeter over there. 7 millimeter, as it is shown the displacement in the form of amplitude having at this value like 7 over there. Okay, we will have to move this. Now, what is he saying over there? The stationary wave is produced by two progressive waves traveling in opposite directions on the string. We remember that this one wave is going in this format and one wave is coming in this format. So this wave is going, this wave is coming back, and these two waves are showing as overall. If I take the single wave, that is a progressive. If I take both simultaneously in opposite direction, then I will say it is a stationary wave. Reduce the amplitude of one of the progressive wave over there. So the stationary wave has an amplitude of what? That is approximately, I will say 7 millimeter as the amplitude over there. And a stationary wave is formed by two identical progressive waves interfering over there, as I have shown here. So I will say the maximum displacement of the stationary wave is twice the amplitude of the wave of compressive wave over there. So I will say it is like 8 to be shown for this one, like 7 is shown for this one. Then I will say it will be half. So amplitude of one progressive wave will be shown as 7 divided by 2 will be 3.5 millimeter can be taken as the amplitude over there. So it will be 3.5 millimeter. I have taken that the amplitude of single progressive wave will be taken as 3.5 because the overall amplitude of the stationary wave, which was taken like in this form, in the form of antinodes over there, is shown on the graphical representation of the displacement over there. That was 7. I have just made it half over there. After that, he is saying determine in meter per second the speed of the progressive wave. So, if we go for this one, then I will say speed of one progressive wave. So from the figure, the length of the string, as I have shown over there, that is 1.05 meter. 1.05 meter is the length of the string over there. So for we can say it corresponds to 1.5 wavelength over there. It is showing 1.5 lambda as its wavelength. So I will say it will be equal to 1.05. So my lambda will equal to 1.05 divided by 1.5. Let's check what it is giving us. 1.05 divided by 1.5 will equal to 7 by 10, which is equal to 0.7 meter. 0.7 meter, and frequency is 625 hertz. So I'm using the formula V is equal to F lambda. So it is 0.7 for wavelength and frequency is 625. So 625 multiply 0.7 multiply 625 is equal to, this is equal to 437.5. 437.5 meter per second will be the answer for this one. State the phase relationship between two waves when t is equal to 0, like that. Then I will say here that at t is equal to 0, all the points at their maximum displacement, meaning the two progressive waves, are in phase with each other at every point over there, resulting the constructive interference everywhere. Moreover, more precisely, they are in phase at the antinodes, but they the condition for a stationary wave pattern at t is equal to 0. Here I will have to also have to go for a graphical representation in the next part 7.4, but right now I'm talking about 7.3 over there. Okay, they are in phase at antinodes, in phase at antinodes, showing the constructive interference over there by using the two progressive waves over there. and all the points at maximum amplitude require the wave to be in phase everywhere at that instant over there. After that, he is saying sketch the graph on the figure over there. So if I take uh, point S is at anti-node, like by showing the maximum amplitude of the graph over there, then I am saying here that the graph must be cosine curve over there, like this form, where I am taking as 7 on the waveform over there. It should be must a cosine waveform to be shown over there. And the time period will be taken as frequency was how much? Frequency was 1 over time period. So time period 1 over 625, as you have calculated above. This was given in the form of frequency of the source over there. Then I'm saying 1 divided by 625, the time period will be 1 divide 6 to 5 will equal to this, will equal to 1.6 milliseconds. So time is given in the form of milliseconds over there. So 1.6 milliseconds. 1.5, and 1.6 will be here like that. So I will say here that this will be the point again in the form of above section, like 1, 2, 3. It will be taken like this and like this to be shown like this over there. Remember that the below line will also go in the form of exactly being taken the same format to show over there of 7 reach over there and 7 reach over there. Remember that I have tried to complete the time period over there, and the sketch should show a smooth periodic oscillation between +7 and -7, and the time period should be 1.6 milliseconds over there. I tried to take the 1.6 and I tried to keep my amplitude as 7 and -7 to show this complete representation, which he was saying graph or displacement S varies with T over there. I have drawn over there. Okay, now he is moving towards the MCQ questions of section B over there. All right, from question number 8 to onward, he should has to talk about all the MCQs over there. Which nuclear charge results in the nucleus with the greatest specific charge over there? So I will say here the alpha decay of 82290209 nucleus over there. Then which nuclear charge results in the nucleus with the greatest specific charge over there? So I will say here that specific charge is the charge to mass ratio, like beta minus decay increases the proton number should be done over there. Like he is saying beta minus decay should be being taken of a nucleus over there, and increase the proton number by 1, but mass number stays almost the same over there, giving the largest increase in specific charge compared to others, like if I take for alpha, if I take for beta plus or electron capture over there. So the maximum cases beta minus decay will be taken, which will be provided the specific charge as a charge to mass ratio. So beta minus decay increases the proton number by 1, and but mass number stays almost the same, giving the largest increase in specific charge compared to others. Move to question number 9 there. What is he saying here? In two separate experiments, electromagnetic radiations of the variable of frequency f is incident of the surface of plates made from metal X and Y. The work function of X is greater than work function of Y. Which graph shows this? Maximum kinetic energy of the photoelectrons emitted from the surface of plates varies with F. So here we will have to use photoelectric effect, which states that that we can say kinetic energy max will equal to, we can say, energy HF minus work function over there. So he said that the work function is greater for X. Like the work function of X is greater than work function of Y over there. Then I will say here that the graph is a straight line with the same gradient of H for all the metals, but with more negative y-intercept for the metal with the larger work function over there. So X will be straight. It can be right because this is a straight line and X is the greater value of the larger frequency over there. Option A will be fine. Never like this is going to happen, or y with the larger smaller work function is not going to happen. This will not going to happen over there. So option A will be fine for it. Let's move to question number 10 over there. Monochromatic light is incident on a metal surface in a vacuum and photoelectrons are emitted from the surface. The photoelectric current I is the rate of charge from the surface. The maximum kinetic energy of the photoelectrons is Ek max. Okay. Ek max and I are measured. The frequency of the light is then increased. There is no charge and rate at which the energy is incident on the surface. All right. What happens to Ek max and I when the frequency is increased? Okay. If I just observe there, I can simply say here that kinetic energy max increases with frequency equation, as I have told you in the above photoelectric effect equation over there. Then I will say that the photoelectric current depends on the number of photons incident per second. And since the incident power is constant, like P is equal to N H of F over there, and I am taking the number of electrons there. Increasing the frequency means fewer photons per second. So we can say, so fewer electrons are emitted over there. So I will say here that it should go where that kinetic energy max is increasing and current is not changing. Okay, current is not changing, only its kinetic energy is increasing over there. So option B will be perfect for it, where we are saying that the power is increasing and kinetic energy is increasing and only number of electrons is not changing over there, going to stay with it. Okay, here he is saying that this is the energy levels of the atoms are shown E1, -1, -6, -21. Okay, lambda 1 over lambda 2 we will have to take over there. All right, lambda 1 and lambda 2 I will have to go for it. So the energy E1 I will say is equal to -1 -6. -1 -6 is equal to 5 electron volt. That is my energy 1. And energy 2 will be taken as -6 minus 21 will equal to 15. So I will say here I will have to go for a ratio of both of them. Then I will say here that as we know, E is equal to HC over lambda, like that. So lambda 1 is down, then its energy is above, and 2 is, but lambda 1 I need above over there. So I will say here that I will have to take the energy 2 above, energy 2 above, and energy 1 down. So that HC over lambda 2 over HC over lambda 1. This lambda 1 is going to at top and HC is cancelled. Lambda 1 over lambda 2 will be equating the ratio that energy 2 should be taken in the numerator. That will be 15 upon 5 will equal to 3 over there. Let's go for the option over there. That is the option C over there is a right option for this. I think so the concept behind it is much clarified now. Let's go to here. He is saying that an electron and a proton move with the same speed. What is the de Broglie wavelength of proton over de Broglie wavelength of electron over proton over there? So de Broglie wavelength, we know that lambda is equal to h over p, which is equal to h over mv over there. So from here, I can explain that when we take this de Broglie relation for the same speed, lambda is inversely proportional to mass over there. If the speed is same over there, then it will be inversely proportional to mass. And we can simply say here that I should go for mass of proton over mass of electron, then I will say it is approximately equal to 1836 over there. Then 1836 will be the ratio of mass of proton to mass of electron over there. Then where is the option D is given? No, it is not mentioned over there. No problem. I'm writing here 1836. That will be taken in this format. Okay, here he has shown that a laser light emits the wavelength of 600 nanometer for 10 nanoseconds over there. And what he is asking, what is the number of complete waves emitted by the laser over there? So for this one, that number of waves will be taken like speed of light multiplied time divided by I will say wavelength over there. C is speed of light 3 multiplied 10 raised to power 8 multiplied time is 10 nanoseconds 10 raised to power minus 9 divided by 3 multiplied 10 raised to power 8 divided by wavelength 600 multiplied 10 raised to power minus 9. Minus 9 gone with minus 9. 10 is gone with 10. And 3 1 time 3 2 times 20. 10 is to power 8. So 1 by 2, 10 gone with 10 is power 7. 0.5 multiply 10 is to power 7. So I will say here that it should go with 7, 9, 10 nanoseconds. Minus 9 is gone. And I should take the answer which will equal to 5 multiplied 10 raised to power 6. So it has not written properly over there. 10 raised to power 8 is like this. And 5 multiplied 10 raised to power 6 is option D should be taken over there. So I will say it will go with 1 by 2 is 0.5 multiplied 10 raised to power 7. So 5 multiplied 10 raised to power 6. I have taken this answer as D over there. Let's move to question number 14. A detector measures the intensity of light source S1. The polarized material is placed between source S1 and the detector. When the material is rotated through the small angle, the detected intensity does not change. When this procedure is repeated for S source S2, detected intensity decreases, which is correct over there. So for this one, I will say that rotating a polarizer causing no intensity change. And if the light is unpolarized like S1 and a change if it is polarized S2. So option A will be fine for this one over there. My explanation, which I have done for this one, I think so will be clarifying your answer here. For question number 15, a loudspeaker producing a single frequency sound is mounted above the tube filled with water. A tap with the bottom of the tube is open to allow the water to run out. Okay, L1, L2 is the heights over there. He is saying that a student observes a change in loudness of the sound emitted by the tube in the water runout when the length of the column of air in the tube reaches L1, the loudness of the first maximum, and the next maximum is when the column reaches to L2. What is the wavelength of this sector over there? Then I will say if we observe here, then for the first resonance is closed when L1 is will be like lambda by 4 there. One end is closed. Then I'm taking the first length L1 should be taken as lambda by 4. And for the next resonance, I will say L2 will be taken as 3 lambda by 4. I am just using the stationary waves when one end is closed over there. Then it is length is lambda by 4 and 3 lambda by 4 can be taken. So meaning that their wavelength will be taken. Then we will say the difference between both of them. If I take L2 minus L1, then I will say 3 lambda by 4 minus lambda by 4. 3 lambda minus lambda, 2 lambda by 4. It will be lambda by 2 over there. So I will say that my wavelength will equal to 2 into L2 minus L1. Let's check if the answer is there. Lambda is equal to 2L2 minus L1. So option D will be fine for it. You can check again what I did for this. I'm just using the formula cases for wavelength and length for one and close of making the Snell U over there. Let's move to question number 16 there. Point sources of the sound of same frequency S1 and S2 are given. All right. Then what he is saying, a sound detector is moved slowly along the line PQ. Okay, this is the line PQ. It is slowly moved and consecutive maxima of sound intensity is detected at W and X. Okay, W and X means in the center and at X also. Consecutive minima are presented at X and Z over there. So minima is done at X and Z over there, and maxima is W and Y. So W and Y are observing the maxima over there. What he is saying there, consecutive maximum. Okay, what is the wavelength of the sound over there? So for this one, I will say that S1Y minus S2Y will be being taken S1Y minus S2Y should be being subtracted from S1X minus S1X minus S2X will equal to your wavelength lambda S1Y minus S2Y S1Y minus S2Y minus S1X minus S2X. So I'm going with option C over there. I think so. The concept behind it, which we use from the Young's double slit experiment over there, we have summarized this one over there. Monochromatic light is used in Young's double slit interference experiment after passing through a single slit. The resulting fringe pattern is observed on a screen. The separation of the fringes can be increased by using monochromatic light of lower frequency over there. So this is the right one option over there. As we know that the fringe separation, like we can say where I can say fringe spacing like delta y will equal to lambda d over s over there. If we observe this relation, lower the frequency means longer wavelength, and lambda is cf, which increases the fringe spacing. So option A will be perfect for it. No need to go for the other one if you know exactly the mathematical expression over there. Okay, a force of magnitude F acts on a box of mass M that moves along the frictionless slope. The slope is at an angle alpha to the horizontal, for the force acts at an angle beta of the slope over there. Alpha and beta are given over there. What is the magnitude of acceleration of the block along the slope? So for this one, I will say here that resolving the forces, the component F along the slope will be F cos beta. If I take along this one, then I will say it is F cos beta should be taken over there. And the component of weight down the slope will be mg sine theta. Mg sine theta, I can say. Yeah, mg sine alpha. And that will be mg sine alpha. Sine alpha over there can be taken into account. So I will say here that so net force along the slope will be F cos beta, F cos beta minus mg sine alpha there. If we go for mg sine alpha, then we can say that the acceleration will equal to net force divided by mass. So from here, I will say that acceleration will equal to net force is this divided by mass over there. So for g sine alpha is remaining as it is. So it should go with it is f divided by cos beta minus g sine alpha will be correct one for this one. Okay, number 19, the weight of a uniform bar is W, and object is also the weight W is attached to one end. The bar is pivoted at the other end, held horizontal by a rope attached to its center. The tension in the rope is 4W. Okay, this one is W, this is 4W. And what is he asking over there? What is the angle theta over there? So for this one, I will say taking the moments about the pivot, let the length be 2L. Okay, length will be 2L over there. Then I will say here that the weight of the bar W acts at L from the pivot, and the object W acts at 2L, and the tension 4W acts upward at L point of width. So I will say here that I will have to take W multiply L will equal to W, sorry, plus W multiply to L will equal to 4W multiply L into sine of theta. If we use this relation, we can W say like WL, 2WL and 4WL. So WL, it will making 3WL divided by 4WL. WL is cancelled with WL over there. And if I make the subject over there for sine theta over there, then I will say here that sine theta is equal to 3 by 4. So theta is equal to sine inverse 3 upon 4. Let's go for it. Shift sine inverse fraction introduce 3 divided by 4 bracket close is equal to 48 degree like that. 48.6 degree. So what is their value? 41. What I got is that was 48 over there. So closest option is A, 41. That might be the misprint using the standard calculation. A is closest, but math gives like 49 there approximately. So I will say it should go with the 41 with A. Might be possible there is a misprint or some error over there that has occurred over there. A projectile is fired from the ground level horizontal ground. Its initial velocity u at t and angle theta horizontal. The range of the projectile is d. Okay. A second projectile is fired with velocity at 2 theta, the same angle over there. What is the range of the projectile? Assume the resistance is negligible over there. If you just observe here he has initial speed is this given over there. Then the range will be given by the formula. Range is given by the formula u square g sine of 2 theta like that. This is the range formula over there. So we can say range is directly proportional to speed square over there. So doubling u, like u square, he is doing doubling over there. When u is doubling, it means that we can say it quadruples the range over there. So if it is quadrupling the range, then I will say it is going to take 4D over there. Quadrupling means 4 times making increase over there. So here he is saying a particle traveling horizontally at 1 multiplied times power 7 meter per second and enters a region where it is constant vertical acceleration 4 multiplied times power 14 meters per second square. Okay. What is the horizontal distance the particle has traveled in the region when vertical displacement is 8 multiplied times power minus 2 meter over there? So for this one, number 21, here he is saying a particle is traveling at this speed, enters a region where it has constant vertical acceleration of 4 multiplied times power 14 meter per second. What is the horizontal distance of the projectile over there? So for 21, I will say here that vertical motion is being taken as like Sy is equal to, I will say here vertical, like third equation of motion over there. Then I will say here that Sy is equal to, because initially we can say in case of vertical distance in projectile case, we take only half ay t square over there. Then in that case, I will say if I take its complete form over there to calculate the value, then I will say that it should go with half a t square ay t square, and ay is 10 to the 4 multiplied times power 14 and it is 10 to the power 7. So I will say here that 0.5 multiply 4 multiplied times power 14 multiply t square. If I make t square as subject, then I will say 4 multiplied times power minus 16. Okay. And the horizontal motion like Vx multiplied by T, then I will get 0 0.2 meter. Let's check if it is 0 0.2 meter. I think so option A will be fine for it. That is 0 0.2 meter. The calculation which I have stated with you, you can calculate on your by your own. An object is thrown vertically upward at time t is equal to 0. The object reaches a maximum height when t and reaches the terminal speed of the way round. The magnitude of the object's acceleration is a, which graph represents. If you remember the acceleration time graph over there, then I will say here, yeah, option C will be perfect for it. When you have reached the terminal velocity, then acceleration is getting uniform over there, and after that, we can say it is going towards 0 over there. In number 23, he is saying a man has a mass of 75 kg and he stands on weighing scale in a lift of accelerates upward 2.60. What is the reading on the scale of the acceleration over there? 75 into 2, 300, and downward 750, and 300. 0.6 is also being taken. So approximately, I will say that here you will have to take R minus mg is equal to ma. Then I will say here that R is equal to m into a plus g. So m is equal to m into a plus g. So a is 2.60 plus 9.81. Let's go with it. Uh, like 75. And I am taking the 75 kg over there. Let's go for 75 multiply bracket start 2.6 plus 9.81 bracket close. It will equal to this will equal to 930. Let's check which is this one. Yeah, 930 option D will be perfect. Okay, number 24, he is saying there an average force of 42 kilonewton acts on the air passing through the jet engine. This force causes the speed of the air to increase by 540 meter per second. What mass of the air passes through the engine in 1 minute? Okay, so we will have to use what mass of the air passes. So I will say that I will have to go for force to change in momentum, like in the form of impulse over there. Then I will say that if I take impulse, like force multiplied time is equal to delta P over there. And delta P, I take mv also over there, F multiplied T over there. Then I will say here that F should be taken as 42 kilonewton he is taking over there. So I will say that go for first of all, go for force multiplied time to be taken to get the momentum over there, and then divided by speed. So 42,000 multiply by divided by 540 multiply by time is 1 minute. So I will say go for 60 seconds to be taken over there, and you will get multiply by 60. So go for it. 42,000, 42,123 multiply by 60 divided by 540 is equal to this, is equal to 4666. 4666, option D will be perfect for this. Let's move to question number 25 there. A uniform wire is stretched by a load F. The elastic strain energy stored in the wire is E. The load is increased from F to 2F. The wire obeys the Hooke's law. What is the increase in elastic strain energy in the wire? Like F is doubled. And if you remember that when we are going towards the uniform elastic limit, within the elastic limit over there, then we will say that F is done from F to 2F. So 1F is present and 2F more is added over there. So it will be taken as 3 times to its energy. And then I will say like elastic potential energy is, let's suppose I'm using the formula 1 upon 2Fx. And now he is saying that it is if F doubles, K is constant and X doubles, and new energy will be taken as E is equal to 1 upon 2 with the 2F with the 2X also. Then I will say here it will be 1 by 2 into 4Fx. So it will be 4 original F X over there. It is 4 times. So he said, what is an increase? So 4 minus 1 will be 3. So it will be 3E should be taken as the difference of both of them. So I will say it should go with option C over there. I think so. The concept behind it is clearly put in your mind. Okay, here he is saying a spring is compressed by a force F, and a spring has a stiffness as a spring constant, its length changes by delta L during the compression. When the force is removed, the spring returns to its original length in time t. Okay, what is the average power developed by the spring in return to its original length over there? So for this one, I will say here that we remember that average power is equal to total energy returned per unit time. So the energy stored by this is being taken 1 by 2k into delta L square over there. So that energy which I am using according to strain energy of the elastic spring over there, then I will say here that we should say that the average power should be being taken by 1 by 2k delta L square divided by time over there. Let's check if it is written over there. Then 2 with the t over there. Yeah, this one will be fine over there. K is a spring constant, delta L is extension like x, and divided by time and also divided by 2 over there. A 12 ohm resistor is connected across the terminals of a battery of EMF 20 volt and internal resistance 4 ohm. What is the potential difference across the resistor over there? So we will say here that the total resistance will be 12 plus 4 will be 16 over there. 16 ohm will be the total resistance over there. And for getting the current over there, I will say I will equal to 2 upon 16, which is equal to 1 upon 8, which will equal to 0.125 ampere. So potential difference across the resistor 12 ohm, I will say IR will equal to 0.125 multiplied 12, which is approximately equal to 1.50 volt. So option D will be perfect for it over there. Let's move to 28. What he is saying there, a small mass is placed, okay, a small mass is placed at position P over there on a horizontal turntable. The turntable rotates clockwise at a constant angular speed about the vertical axis through its center O over there. Okay. And the mass remains at rest relative to the turntable. What is the direction of frictional force on the mass of that instance to be shown over there? So if I talk about it, then I will say here that the friction provides the centripetal force for circular motion. The centripetal force is directed towards the center at O over there. Then I will say here that at the instant shown, the direction from P to the center of O is P to S, like that. Like P to S can be shown with the help of direction over there. So for this one, I will say that P to S, option D will be perfect for it. P to S over there. Okay. In number 29, he is saying a particle of mass m moves on a circular radius. Um, or the number of revolutions completed per second is F. What is the kinetic energy of the particle? So for the kinetic energy here, as we know the basic formula, kinetic energy is equal to half mv square. Then I will say V should be taken as V is equal to R omega. Then I will say that it should be written with omega is equal to 2 pi F with R. If I am taking with R omega, then my V will become 2 pi F R. That will be equal to V 2 pi F for omega, and R is as it is over there. So kinetic energy will be equal to 1 by 2 into M into 2 pi F R whole square can be taken into account. So I can write it from here 1, 2, because of the power 2 will be cancelled, and 2 M pi square F square R square. So 2 pi square M F square R square, option B will be perfect for it. Okay, let's move to question number 30 there. A body is in simple harmonic motion of amplitude 0.60 meter and a period is 2 pi seconds. What is the speed when its displacement is 0.20 meter? So for this one, I will say here we know for simple harmonic motion that V is equal to omega under root amplitude square, like x naught square I am taking here, minus x square as a displacement square over there. And then I will say that my omega, we know that is omega is equal to 2 pi over t over t. So 2 pi seconds he is taking the period. 2 pi is gone. So omega will equal to 1 over there. So it is 1. So I will say here that your amplitude is 0.60, 0.60 square minus your displacement is 0.2 square. Square root will give you the speed over there. 0. Let's go for it. Square root 0.60 square minus 0.20 square will equal to this, will equal to 0.56, like 0.57 can be taken into account. So this will be option B there. Let's move to question number 31 there, where he is saying when a mass m is suspended from a spring, the spring extends by a distance x M is displaced vertically when released its oscillation with the period T. M removed with suspended from a different spring. The spring extends by a distance of x by 2. M is again displaced vertically and released. What is the new period of oscillation of M over there? So for this one, I will say that we know that in case of mass spring system, the T is equal to 2 pi under root M over K is the main relation for the time period. So from Hooke's law, I will say that weight mg can be taken as kx. So my k is equal to mg upon x over there. So T is time period is directly proportional to under root of x over there. So I will say if the new extension is x by 2, then time period will be t under root 2, t over under root 2. So option B will be perfect for it. Here he is saying a mass spring system of a simple pendulum have identical periods of oscillation time t at the surface of the earth. Both are taken to planet X. And what is the acceleration due to gravity is g. What is the period of mass spring system and simple pendulum of X? So period of mass spring system and period of simple pendulum over there. If we take into account, then period of mass spring system is again I can say T is 2 pi under root M over K. If I observe this formula, there is no involvement of G over there. So I say that its time period is totally independent and period of pendulum is inversely proportional to square root of G over there. If I take the formula, T is equal to 2 pi under root L over G. So T is inversely proportional to 1 root under root square of G over there. If G halves, then I will say if it is getting half, then time period will become T under root 2 times can be taken over there. So option C will be perfect for this. That time t is independent and it is defected. So this is okay. This was your whole paper, which I tried to explain according to my point of views. And if you think that it is very helpful for you, kindly comment me and subscribe the channel, share the video with your classmates so that they can also get the benefit by watching this video. Thank you so much for today class. It was really, I will say overall, it was a good class. Thank you so much.